On an island that can support a population of 1,000 lizards, there is currently a population of 600. These lizards have a lot of offspring, and not a lot of natural predators, so they have a very high growth rate, which is about 150%. The next couple generations. This is a logistic growth model. We have an island that can support a certain population. We have a restriction, a carrying capacity. So our logistic growth model is P sub n equals P sub n minus 1 plus R times 1 minus P sub n minus 1 over K times P sub n minus 1. Our initial P naught is the 600 lizards. To find P1, we then do P naught, which is 600, plus R, which is 1.5. It's the growth rate in decimal form, times 1 minus the current population of 600 over the carrying capacity of 1,000 times the current population of 600. We can plug this into our calculator. 600 plus 1.5 times 1 minus 600 over 1,000 times the 600. We get 960. That is our population. That's the next generation. We have 960 lizards. Now for our second generation, we plug that in. We have 960 plus 1.5 times 1 minus 960 over 1,000 times the 960. Now we can plug that into our calculator. 960 plus 1.5 times 1 minus 960 over 1,000 times the 960. We'll round this to the nearest whole number since we're talking about the population of lizards. This is about 1,018. Let's do one more generation to see what happens. Notice that our population right now is over the amount that the island can support. So what we should expect for our next generation is for our population to drop. Let's see if it happens. We have 1,018 plus 1.5 times 1 minus 1,018 over 1,000 times the 1,018. Plugging this into our calculator. 1,018 plus 1.5 times 1 minus 1,018 over 1,000 times the 1,018. And we see that it dropped down here. Again, rounding to the nearest whole number, we have about 991. So we see that it's doing what we expect. It grew, and then it grew again, but then it's because it passed the carrying capacity, it needed to shrink because the island could not support that many.